Now this is a quadratic absolute value. However, it doesn't really matter in that it still goes through the same process. We still want to isolate the absolute value. Okay, so we want to get the absolute value, undo the minus with a plus, and then at this point we ask, well, the possibilities, what are the possibilities when the inside equals 6 and when the inside equals negative 6? So I still do the same process. I still have my positive version. And my positive version is going to be when the inside equals positive 6. And I also have to consider my negative version because I'm going backwards through that absolute value function. We have to go from positive to plus minus. So my inside, x squared minus 10, it's possible that could have been equal to negative 6. Okay, so there's my two possibilities. I'm going to solve both of them. So I'm going to solve for x squared, and I can undo the squared with a square root. But remember that when you're solving by square rooting, we have to consider the plus minus. So we get plus minus 4. Okay, so there's the positive version. Solving this, I'm going to add 10 to both sides. I'm going to undo that square by square rooting, and I get plus minus 2. So I actually have 4 solutions here. So I better test all of these solutions. So I'm going to test. Okay, so x equals 4. 4 squared minus 10 is 6. Absolute value is 6 minus 6. Okay, so we get absolute value 6 minus 6 equals 0. Yeah, that's okay. Let's test negative 4. Well, if positive 4 works, we're going to square it anyway. So we get squared minus 16 minus 6, minus 10 is equal to 6 minus 6 equals 0. Perfectly good. Those are both perfectly good solutions. Okay, so let's test the negative 2 and positive 2. So let's test x equals 2 first. I get 2 squared minus 10 is negative 6. Minus 6 equals 0. Yep. That's going to give us 6 minus 6. That's okay. And then testing x equals negative 2, well, we can kind of see it's going to do the same thing. Negative 2 squared is 4. Minus 10 is negative 6. Absolute value of negative 6 is positive 6. Minus 6 equals 0. That's good. So in fact, we have 4 perfectly valid solutions. And if you recall what the graphs look like, you can probably justify this. Okay, and again, it's a good idea to take your graphing tool and graph these solutions, and you can see visually what these solutions look like, and it gives you a better sense and understanding of why we're getting answers that look like what they do when we solve these algebraically. So the last thing here then is, let's take a look at situations where we have absolute value and linear equations that have different numbers of solutions. And this will help us justify why we have the different possibilities for our absolute value equations. So an example of absolute value in linear system, so one absolute value in a one line, if I have 0 solutions, okay, so this is my A, I could have a V-shaped graph like this, and I can have a line that does not cross. So that's 0 solutions. For B, 1 solution. Well, we saw an example of that when we drew it. So we have our V-shaped graph here, and we can have the slope of this graph such that it would never intersect one arm but doesn't intersect the other arm. So there's 1 solution. Okay. We could also actually have an alternative situation, and some of you may have thought of this. So this is an alternate B, okay, where we have a V and it might just touch at the vertex. And so that's possible to get 1 solution as well. And lastly, to get two solutions, okay, so this is two solutions. So if it's linear, we have our v, and then we have a graph that crosses both arms like this, and that will give us two solutions. Okay, so these are the three different scenarios we could have. We could have no solutions, okay, and we could still have extraneous solutions. If we actually trace this back, there could be extraneous solutions that cross. We could have one solution with an extraneous as well, okay, or we can have two solutions that don't have any extraneous solutions. Okay, so those are our three situations that we have to consider, and again, we're thinking about this in terms of shapes of the functions.